Hello students, in the previous lecture we have discussed first law of motion, second law of motion, inertia and its different types. Today we will discuss impulse, Newton's third law, law of conservation of linear momentum and its applications in real life. Impulse. What is this impulse? Whenever any force is applied on a body for short interval of time, then the effect produced by the force is called impulse. Mathematically, it is equal to the product of force and time. Its SI unit is Newton's second and dimension is ml t minus 1. As velocity is a vector quantity, so impulse is also vector quantity. If force F is applied on a body for very short interval of time delta t, then impulse I equals to force into delta t. According to Newton's second law, F equals to delta p upon delta t. So, F into delta t equals to delta p. So, impulse I equals to delta p. Let us repeat our previous numerical. We have a ball of mass m moving with velocity v. If angle of incidence is 30 degree with the vertical, then resolving linear momentum Pi into its rectangular components. Pi equals to mv cos 30 along I minus mv sin 30 along j, and after collision linear momentum Pf equals to mv cos 30 along I plus mv sin 30 along j. So, change in linear momentum delta p equals to p final minus p initial. So, delta p equals to 2 mv sin 30 along j. Substituting the value of sin 30, we get delta p equals to m into v. Now, if contact time is delta t, then force equals to delta p into delta t. So, F equals to m v into t. Now, let us start with Newton's third law of motion. In the previous topic, we have learned about an external force. What is this external force? Obviously, any other body can apply external force on a given body. Newton said force always act in pair and in opposite direction. If we have two bodies, say A and B, A exerting force on B, B exerting force on A. If FAB equals to force on A due to B and FBA equals to force on B due to A, so according to Newton's third law of motion, FAB equals to minus FBA. Negative sign, it indicates the direction of force. That means, the two forces are equal in magnitude, but in opposite direction. This pair of forces is also known as action-reaction law. Law of conservation of linear momentum. It states that if no external force is acting on a body, then its linear momentum remains conserved. Let us say we have two objects A and B, their masses are m1, m2 and they are moving with velocity Pa and Pb. So, initial linear momentum of A is Pa and initial linear momentum of B is Pb. Let the two bodies collide for a short interval of time delta t. If Fab equals to force on A due to B, FBA equals to force on B due to A. According to Newton's third law, Fab equals to minus Fba. If we multiply both the sides by the time interval delta t, then we get FAB into delta t equals to minus FBA into delta t. According to Newton's second law, FAB into delta t is equals to change in linear momentum. So, FAB into delta t is equals to delta PA and FBA into delta t equals to delta FB. Substituting these values, we get delta PA equals to delta PP. P dash A minus PA equals to minus P dash B minus PB. Opening the bracket in the right hand side and transposing, we get P dash A plus P dash B equals to PA plus PB. That means the initial linear momentum of the system is equal to the final linear momentum of the system. Hence, the law of conservation of linear momentum. That means the initial linear momentum of the system is equal to the final linear momentum of the system. Let us recall a numerical based on the law of conservation of linear momentum. For example, recoiling of the gun. Let we have a gun of mass m. Mass of the bullet is small m. Initially, the mass of gun and mass of the system both are to be taken together and the velocity of the system is 0. So, initial linear momentum of the system is 0. Now, the bullet is shot and velocity of the bullet is v. Let the velocity of the gun is capital V. So, after bullet is shot, the final momentum will be equals to capital M, capital V, which is for the gun, plus small m into small v, which is for the bullet. According to the law of conservation of linear momentum, final momentum equals to the initial momentum. So, capital M capital V plus small m small v equals to 0. Transposing, we get velocity of the gun capital V equals to minus small m small v divided by capital M. Equilibrium of forces. Forces acting at a point are said to be in equilibrium if the resultant of all the forces is 0. If for any object we say only two forces F1 and F2 are acting and the two forces are in equilibrium, then F1 plus F2 equals to 0. According to Newton's third law, F1 and F2 have to be equal in magnitude and they have to act in the opposite direction. Now, if we say three forces F1, F2 and F3 are acting on a body at different angles in such a way that their resultant is 0, then vector F1 plus F2 plus F3 equals to 0. That is possible using the laws of vector addition. The resultant of any two forces should be equal in magnitude, but in the opposite direction to the third force. Let us discuss another situation based on the same topic. If we need to calculate apparent weight of a man in an elevator, then let a man of mass m is standing in an elevator. Initially, if the elevator is at rest or moving with uniform velocity, then weight W equals to mg. According to Newton's third law, normal reaction offered by the elevator is also mg. Now, if we say elevator starts moving upward with an acceleration a, then the apparent weight offered by the elevator W dash is equal to mg plus ma. So, the person experience more weight. If we consider another situation in which elevator starts moving down with an acceleration a, then the apparent weight W dash will be equals to mg minus ma. In this situation, the person feels reduced weight. If a body is falling freely, then apparent weight equals to 0, and we say that the body feels weightlessness. There is a misconception about this term weightlessness. Normally people say that weightlessness means the body experiences no weight. It means either the body is not having mass or it does not experience acceleration due to gravity. But both the situations are not possible. It means something else is there. What is it? And that is, according to Newton's third law, we get that body does not get any normal reaction. As a result, body is falling freely under the acceleration due to gravity. In this chapter, we have learnt about Newton's third law, impulse, its real life based applications, and in the next lecture, we will discuss about friction, circular motion, advantages of friction, and requirement of circular motion and banking of roads. That's all for today. Thank you.